Welcome to the week 14 lesson plan. I'm doing this week remotely, as previously mentioned in the email I sent out. So let's get to it. We're going to start off by reviewing last week's, and that was 9.3, and we're looking at this set of plans. And I didn't really see anything on that plan set that needed reviewed except for the final question, question 4. There's a couple of them on there I just want to kind of review quickly. First one is, what is the height specified for the standard teller counters? That's the second item on question 4. The height of the standard teller counter. So you may have found as you were looking at the plan set that the teller counters are not all the same height. We're just looking for the standard height, not the handicap accessible height. So let's go ahead and jump down to the details that cover that area. So you can see right here on the first floor plan, we can just kind of follow the breadcrumbs here. You can see the overall enlarged floor plan is going to be on sheet A 10.1. So way down here in the plan set. And here we are on sheet 10.1. And the teller counters, those are these right here. And this one right here is the lower one. You can see that that one is 30 inches high, as indicated with this little elevation marker right here. The other ones, however, are this high. So this is the counter itself, 40.5 in height. If that didn't make sense to you, or if you missed that, you may have also gone and taken a look at some of these section views. And I don't know off the top of my head which ones do or do not have the height of the counters. And if you saw this one right here, you can see that this is actually referring to an upper shelf that's adjacent to the counter. It's a little bit hard to make out until you look at the elevations of these things, which are also available on sheet A 10.1. But let's take a look at sheet 10.2 because that also has some information on there. And that counter height information is actually available in a number of different locations. This section right here does a really nice job of laying out the size of really every component on those teller counters. And you can see right here, 3 foot 4.5, also listed as 40.5 inches up to the top of that counter. The other one I wanted to review was seventh one down on number 4, also on number 4. And that one asks, what is the nominal size, that is not the actual size, but the nominal size of the framing lumber used for the partition between each walk-up teller window? So as you can tell, that's going to be in a similar area. Let's go back to the enlarged floor plan and let's see if we can identify what are those partitions separating the teller windows. That's basically these things right here. So this would be a partition separating the handicap accessible window from the first standard window right here. And then we have another one right here and another one right here. But unfortunately, you're going to have to dig a little deeper on that one than just looking at the plan view, which says the framing is 3 inches wide. You're really going to have to get down to a section view of one of those, and you can see right here there is a section view called out going right through one of those partitions. So let's go ahead and take a look at detail 12 on sheet A 10.2. Let's see what that has to say. So detail 12 is kind of down near the bottom of the sheet, over a little bit, and it's right here. This is our detail number 12, and if you look at the partition itself, you can see that we have some keynote here pointing to that framing lumber, and you can see that the actual width is 1.5 inches. So those two things are clues. Right? Let's see what keynote number 7 has to say. It just says wood framing at 16 inches on center. So that doesn't really help us with the nominal size. The 1.5 inches is the actual size because it's in a dimension and it has the inch marks in it. But if you look down a little bit farther, here we have the word, whoops, go back up here. Here we have the word 2 by 2 listed right there. So that was what we were looking for on that one. The framing for that particular partition is using 2 by 2s, which, as you may recall, are actually 1.5 inches wide. The 3-inch width referenced on the plan was actually the framing lumber and the plywood on each side of it. So if you have any other questions on this assignment, go ahead and reach out. Otherwise, we're going to put that one in the books and move on to the next one. And the next one is 9.4, which is covering the structural sheets for the same building. So we're going to start off with structural sheet 0.1, which is just talking about some code requirements for the structure, including the structural steel, the concrete, and the masonry components of the project. So we're not going to do an in-depth tour of this sheet. We're going to move on to the next one. This is talking about the wind uplift. Remember that roofs have to be designed to carry the load of all the stuff on them like snow, but they also have to resist the uplift, the tendency for them to take flight in high winds. And so this is just sort of outlining the locations where there's going to be standard or high levels of uplift based on various calculations that are done by the structural engineers. This is estimating the amount of snow buildup on the lower roofs, and you can see that those are all kind of outlined with these little diagrams right here. Those are the anticipated amounts of snow and their approximate weight per square foot. Moving on, we have the structural notes. Most of them are general notes, but all kinds of detailed information found in there. And spoiler alert, you're probably not going to find a lot of questions on this sheet, but be prepared just in case. I snuck one or two in there. So getting to the heart of the structural sheets, we're going to start off with the basement floor slab plan. We can kind of zoom in on this thing and kind of take a look at what's going on here. This is all about the concrete work, and so all of the loads from above are coming down and have to be supported by the various concrete components, and those typically are going to go in first. All of those loads need to be calculated by the structural engineer, and all of those components need to be sized accordingly. Not just that, but also the dirt work and all the preparation work that happens underneath the concrete needs to be taken care of. Those were handled by a different subcontractor though. That's going to be more of a civil engineering issue. So the structural engineer is calling out things like the size and the thickness of the foundation wall, which you see around the perimeter. Underneath that foundation wall, you see it flanked by a couple of hidden lines. That's the footing that foundation wall is sitting on top of, and you will be able to see what that looks like in profile or in section view when we look at some of these section sheets or section details on sheet 5. But you can see the thickness of the foundation wall is called out on this plan. There's also a bunch of these hexagon shapes with letters in them. We're going to take a look at what that means exactly. There's a general note here that talks about the floor slab. So even though we can't really see the floor slab in this view, it's just sort of this white space out in the middle, it is called out right here. It's 4-inch concrete slab on grade, and it talks about the reinforcing that's going to go into that slab as well. Right underneath that, you can see a little symbol that looks probably familiar by now. That's the elevation symbol, and we can see that the elevation of this thing that it's calling out is 88 feet. So that's relative to the 100-foot elevation of the main floor. So obviously this is the basement. This is down far below the main floor, and there's the abbreviation TOC. Take a minute and try to guess what that means. And if you guessed top of concrete, you are correct. So that would be the top of the slab. It needs to be finished at 88 feet or roughly 12 feet below the main floor. Further down here a little bit, you can see that there's this funny little dashed line that's creating a big square around this smaller square in the middle. And you already probably figured out that this is going to be a column sitting on top of a very large column footing. So we can imagine that there's very heavy concentrated load coming down through this steel structure as it is. This is an HSS column, which describes what the abbreviation here is. This one happens to be 5 inches square by 1/2 of an inch thick of steel. So that's basically a steel plate that's bent into a square shape and then welded along one side. So the majority of this view, this detail that we're looking at of the basement, it will consist of all of those elements I just described. We have columns, column footings, foundation wall, foundation footings, and that's pretty much it, except for one other component that we're going to look at next, and that is these walls right here. These are structural components, basically load-bearing walls, and those two are sitting on top of spread footings just like the foundation is. So this is also being called out as a shear wall, and then it has a little note here that says see plan notes. So usually we're going to be able to find general notes about something like that on the same sheet, and that's true here. So let's kind of come down here and see what it says about that shear wall. So you can see it indicated here with a symbol, and it talks about 2 layers of 15/32 APA rated 32/16 span rated sheathing. So that's basically OSB or plywood, 1/2 inch nominal thickness. Goes on to talk about how that thing should be nailed. And so this thing not only is going to be supporting loads from above typically, but it's also going to be acting as a shear wall, which basically gives the structure lateral stability as well. Now, what portion of the structure it provides that lateral stability to isn't really clear just from looking at this, but we know that it not only has to provide strength from above, but also from one side or more. Another unique thing about this plan is that the footing is not the same elevation all the way around. So we had to step that footing, and you can see that noted right here. It says denote step in top of footing, see plan notes, and that is detailed in the plan notes as well. And if you look closely, you can see that the height of the footing, again relative to the main floor set at 100 feet, is listed here to the top of footing, and then right over here you can see it's all the way up to 84 feet. So it's 87 feet here, sorry, I should say down to 84 feet to the top of footing. So we can see that right at this line right here, this footing steps down a significant amount. And that's basically to accommodate this structure right here, which is, as you may have already guessed, the elevator shaft or pit. Okay, so what are these hexagon shapes? Well, as you may have guessed, that also is going to be keyed on this sheet someplace, and you can find those pretty quickly just by looking over here on the right hand side. Those are the footings, right? Those are the different size footings that we have, in each one of their sizes, and the reinforcing designations are found in this little schedule right here. Okay, so moving up to the next floor, we see the first floor framing plan. And you can tell that the structural floor plans are quite a bit different in their appearance and their function than the architectural ones. The structural plans don't really care about where the walls or the doors or anything like that are. That's more of an architectural function. The structural function is talking about what's holding up the building, right? So we see all of the framing around the perimeter and the size that that is supposed to be. All of that stuff is acting to hold up the exterior part. And then on the inside, we have those columns that are continuing up. Here you can see that HSS column. Again, the designation. This one is 5 inches square by 1/2 inch thick. That's the thickness of the steel used to create that. Over a little bit farther, we can see that there's something else kind of going on right here. A W14 by 30. So what's that business all about? You may remember that from our discussion over the Western Dakota Tech building we studied prior to this one. And the W stands for wide flange beam. So this is basically an I-beam. It's a steel beam coming across from column to column. And this segment right here between these two columns is a W14 by 30. The 14 is the nominal height, so it's not the exact height of that beam, but it's close. And then the 30 is the weight per linear foot. So that thing weighs 30 pounds, just 12 inches of it weighs 30 pounds. So fairly substantial piece of steel there. So each segment has its own particular set of loads that are sitting on that. And so every segment is going to be called out individually. You can see the one just adjacent to it is a W14 by 53, so even larger because it's heavier. That means the steel is thicker. That means it can typically carry more weight. The designation under that, the TOS, stands for top of steel. So the top of that beam needs to be set at exactly 99 feet 0 1/4 inches. So basically 11 3/4 inches below the finished floor height of the main floor. Presumably that is the thickness of the floor. Sitting on top of all that structural steel are a number of structural elements. You can see them all shown with center lines running north and south here. And let's see if we can look around on this plan and figure out where that's called out. It's kind of in plain sight, but also kind of a little bit hard to see. It's actually this call out right here. So you can see that this is a trussed floor. The depth of the trusses from the top of the top cord to the bottom of the bottom cord is 20 inches. And the spacing between the trusses is that goofy 19.2 inches center to center. Just next to that call out is a call out for the sheathing, the subflooring. So APA rated, 24 inches on center span rated, tongue and groove plywood, gives the nominal thickness and how to install it. We're going to glue that down to the tops of the trusses, and we're going to use nails to secure it. Interestingly, we have the top of plywood set at 99 feet 10.5 inches, so a full 1.5 inches below the finished floor height. What do you suppose is going on top of that? Well, you may remember that the main floor and the second floor were both specified in the architectural sheets to have 1.5 inches of gypcrete, which is a gypsum-based lightweight concrete that's going to be poured over the top of it. And that's basically just a sound deadening strategy, so you don't hear as much of the clip-clop of people walking on the floor above you. So that's kind of it on the inside of the building. That's really everything I think that requires a little bit of explanation. On the outside of the building, we have some details for these various structural columns that are holding up, in this case, the drive-through roof. We also have some structural columns holding up some entry canopies, both on the north, the west, and the east sides. So all of those are going to be called out at various places, starting with this plan view here that's talking about the footings, and then also just quite a bit of information about the structural components that are used to build those columns. Moving on to the second floor framing, here we can see that opening that's created in the floor and all the structural components that are used to kind of make that opening possible. You can see the entire thing is sort of bordered by these wide flange columns of various sizes around the perimeter. And then just kind of a repeat of what we saw on the main floor, with just different sizes and spacings for the floor system that we're examining here. The other thing we see on the second floor are the lower roofs. So remember that the building itself is much taller than those various roofs that are around the perimeter, like the drive-through roof. So at this level, although we're looking at the floor of the second floor, we're looking at the roof of the first floor on these perimeter areas. So this is one of those situations where we're looking at roof trusses over here, and over here we're looking at floor trusses. So just kind of keep that in mind as you're going through this. Let's move on to the roof plan. And this one is kind of broken down into, as you can see, separate roof for the upper portion, obviously. So on this plan view, we're not actually seeing the lower roofs. Those were already detailed on the second floor plan. So kind of think of this as a third level almost. And all of the individual trusses are called out. These are using roof trusses out here on the perimeter around the four sides. And then something else is happening in the middle here. These are these giant sort of heavy timber trusses that are going to be left exposed. So those are going to be kind of more of an architectural feature that are left exposed, but they're also doubling as the actual structure of the building. And then of course in the middle here, these are 8 skylights that are sort of flanking the ridge running down the middle here. So along the way, we've seen a lot of call outs for section views, and you can see that every one of these sort of has its own unique little call out for a detail number. This one here, you can tell there's going to be a lot of details when you see the number 43 on sheet S9. That's going to be a scary sheet to look at. Let's go ahead and jump down to S5 first. You can see this is dealing mostly with the structural foundation details. And so all of the section views we've been looking at along the way on these plan views, you're going to find on these next few sheets. So there's sheet S5, there's S6, there's S7. Now we're kind of getting into the upper portions of the structure, including the floor and the roof. S8, quite a bit less going on this sheet. S9, mostly roof components. And then down here, S10, additional roof components. S11 is showing the details of those heavy timber trusses I was talking about on that upper level. And these are left exposed, and so everything needs to be detailed meticulously on a structure like this because we're going to be able to see it as customers and as building occupants. We want that stuff to look really nice. So a whole lot more goes into the manufacture and the finishing of a component like this than it would be if it was going to be hidden above a ceiling, for example. But if you get in, zoom in on this thing, you can see that the detail that has to go into something like this, including the metal plates that are holding the scene together, including all of the holes that need to be drilled through the individual components and bolted together, including really how it's going to tie in with this main ridge beam going across. All of that needs to be figured out, not just in terms of its looks, but also in terms of its structural strength. It's also calling out the type of roofing. So you notice that this is 2x6 tongue and groove decking. That is not the same as what you would see if you were just going to put plywood on top of a typical roof. If we're going to hide the roof structure up inside of an attic, plywood or OSB or something like that is fine. But this particular stuff, because these trusses are so much farther spaced apart, and because the underside of that roof deck is going to be left exposed and visible, that needs to be something else. And that is the final sheet in this set. So not a real big sheet, or not a real big set, just the structural pieces, but plenty to kind of look at, especially in those detail sheets. So do your best with that. Reach out with any questions you have, and we'll see you guys next time in class.